we are at COMTEC, or Macomb County's Communications and Technology Center in Mount Clemens, Michigan. We are located in a 25,000 square foot facility that was pre-existing and which we renovated to make our COMTEC Center. And with the different services we have in here and different departments, we probably service at least half of the county's population, close to 500,000, for direct services with our 911 center. We've had lightning strikes in other areas of the county. So, you know, it's one of our hazards. We needed to make sure that our systems were reliable and that we had lightning protection, and that we use that on our facility and our critical infrastructure and systems in here because we didn't want to have an issue. We made sure that we did this right from the beginning as part of our bid specifications because of the operations that we run here. We needed to make sure that we brought in the experts and someone that knew this field and knew the systems and knew the right way to do it and make sure that we protected our critical assets. This has been a great investment for us. Again, in comparison to the rest of the project, it was a small investment to make, and it pays huge dividends for us because all it takes is one small incident and we're down, and we cannot afford to be down in our type of industry.
For this project, the scope of work that we were hired to do was lightning protection. For that, we use UL 96A, NFPA 780, and LPI 175 as our codes for protection of structures. The R56 did not fall within our scope of work. We did do a site survey, which we came out here, assessed the situation. The building was in a demolition phase at that point, so they were uncovering a lot of walls that we were able to generally see how the building was constructed. And then we applied that and we gave our design engineers guidance with a site survey on how to design the system for this structure. The conductor that we used for this project was, our industry calls it 28R. It is 28 strands of 14 gauge bare conductor braided together, and that is the general wire that for lightning protection industries.
Bare copper, it's exothermically welded to the tower, which means it's heated up to about 1600 degrees and welded to the tower itself. It runs down below grade, where we have a ground ring that encircles the whole base of the tower, and on the other side of the tower there's an identical type of connection.
On one half of the structure, that's what we use because we CAD weld to the steel and CAD weld to the ground rods. On the one part of the structure that's exposed, we use a smaller 29 strand by 17 gauge copper conductor. It's a little smaller and less obtrusive to the eye. We make sure in all of our installations that we make all services common. We tied the electric, the gas, the tower, and the communications are all tied to our grounding system. For the design of this particular structure, it was not necessary to put a complete ground around the entire structure. Existing conditions may have been a factor in that.
As you see here, there's an exothermic CAD weld connection to the base of the tower that goes to the ground ring that is around the base of the tower, the master ground bar, which picks up everything that comes off the tower prior to it going into the shelter. And these are copper ground straps that once again go down and tied to the copper underground ground mat around both structures. Typically on these sites, everything that's metal on the site gets grounded to the same ground mat. Fence, ice bridge, posts that hold up the main disconnects over there, generator, propane tank.
I believe the importance of what takes place in this structure was the driving force behind installing a complete lightning protection system.